Hello, I wanted to answer a question that was asked during class on Thursday, so I'm going to extend just a little bit. So we were talking about this function g of x in class on Thursday, this polynomial function. If you were missing on Thursday, one of the things you need to be able to do is list the possible rational zeros, which we did in class. There's a formula for that, so if you weren't in class, look up the formula to help you answer the questions. These are the keyword possible. It doesn't guarantee that they're zeros, they're just ones you're going to try. That's what we'd start with when we're doing upper bounds. And so we're thinking about the positive values. What is the lowest possible value on the list? That's 1/3. And we turned out, when we did synthetic division using 1/3, we turned out to get a bottom row that were all positive. So you're looking for the lowest positive zero, the 1/3, that will give you all positive in the bottom row. And that would make it an upper bound. That means not to try anything higher. And 1/3 is the lowest one. So that means positive 2/3 won't work. Positive 1 won't work, and positive 2 won't work. So none of the positives are going to work, which we also knew that when we did Descartes' rule of signs. It says if there's no sign change in your original polynomial, then there's zero positive root. So I'm kind of hinting at things, if you weren't here in class, what you need to study and what you also need to review. So then we found that 1/3 is an upper bound. There's nothing higher that will work as a zero. Then we tried to find the lower bound. So you try the negatives. Now I tried negative 1/3 first. And that didn't work. It wasn't a zero and it wasn't a lower bound. I just told you to take my word for it that I tried negative 2/3 at home, and then I tried negative 1. And when I tried negative 1, to find lower bounds, you're looking for when you have a negative up here, and your bottom row here is alternating signs, and that's a lower bound. So negative 1 turns out to be our lower bound. So what does that tell us? That means that our solutions have to be between negative 1 and 1/3. Don't try anything lower than negative 1. So for the lower bound, you're trying to find the highest value that alternates signs. So those are our lower and upper bounds. Well, that kind of eliminates negative 2. And we already had tried negative 1/3 to see. Remember, if this comes out to be 0 right here, then the thing is a 0. So Nick had asked about negative 2/3 because it's the only thing we had left. And I said I had done it at home, and I knew it wasn't a 0. I'm going to do it real quick here. Here's our polynomial again. Oops, that wasn't squared. Plus 2. I'm going to do negative 2/3 to see if it's a 0. Now, it's not guaranteed to be a 0. It's just a possible 0. It's the only possible one we have left. So I'm going to bring the 3 down. 3 times negative 2/3. Negative 2/3 times my 3. Positive times negative is a negative. The 3's would cancel and you'd get 2. Add. I'm going to take negative times negative is a positive. That's negative 2 over 1, which you multiply tops and multiply bottoms. So it's positive 4/3 plus 1, which is 3/3. You get 7/3. If you're not really good with fractions, you can also use your calculator to help you. Then I'm going to take positive 7/3 times negative 2/3, which would give me negative. I'm going to write some scratch work over here. Negative 2/3 times 7/3. That's going to be negative. You just multiply across 14/9, negative 14/9. And then 2 is 18/9. 18/9 minus 14/9 is 4/9. Okay, so I'm looking at this bottom row right here. Notice it's positive, negative, positive, positive. That's not the lower bound. The negative 1 has to be it. You're going to keep going lower until you get the one with alternating signs. It's also not a 0, and that was what Nick's question is. So we've eliminated all our possible rational zeros. I'm going to erase this again. I'm going to sketch the graph of this function real quick. I use my graphing calculator to help me. It has a y-intercept at negative 2 and an x-intercept right around here, and it looks something like this. And that's it has a real zero, but I believe since none of those possible rational zeros, it's real, but it's not rational, or it's irrational, we would say. So I think we have one real zero that's not rational, which I'm curious about. I was a little stumped, and then I think we have two non-real zeros, I believe. I was a little confused about this. Now, I would not ask you to find all the zeros for this, because none of our rational zeros broke this down anymore. I'm going to give you ones where you're going to find one of those rational zeros to work. Interesting, I did some Google searching. I was able to solve this, but I used a very, very complicated process, which is way beyond the scope of this class. And this zero turns out to be approximately negative 0.74, or let's just round here, 7. It goes on. You can use your calculator to find that also, but notice it's between the -1 and the 1/3 that we found to be the lower and upper bound. So we knew there was a zero between there. A cubic has to have at least one zero, real zero. So my belief is that it has a zero that's not rational. You don't need to know that, but I'm following up to answer Nick's question, and also just to kind of review. So remember, for this section, you need to do the possible rational zeros, upper and lower bound. You're asked that specifically in the homework, but I want you to use that more within a bigger problem, and I'll demonstrate that more next week too.